Okay, with number 29, you'll see if you look at the question, you have a rheostat. And a rheostat is a changeable resistor. Okay, so we can change the value of the resistance. Okay, so they say if this variable resistor is decreased, which one of the following is then correct? So we're decreasing our R total. What happens if we decrease R total? Because of our inverse proportionality, we know that our I total will increase, and together with that, our internal potential difference will increase because the battery is working harder. Nowhere did they say anything that the battery's values changed, so to keep this constant, our external potential difference had to decrease. So our ammeter reading is increasing, our voltmeter reading is decreasing, and that then, if you look at the table, will be option B to be correct. Okay. Okay, question 30 is again our straight line formula with a graph. And it's given that our current is our y-axis, potential difference is the x. Okay. So I already manipulated the formula. So the normal ohm formula is V equals I times R. Okay. So now my formula is already corrected for our straight line graph. And they want to know that this is x and that is y. They want to know what is x's value from the options given. So our y-axis is I, and our x-axis can we see as our potential difference. We know it's plus 0 because of the origin. So what's left? Our gradient to be 1 over r, meaning the steeper slope is actually the smallest r. So we need to go and find a value in the options given to be bigger than 1 kilo ohms. Just kilo, just to make it more confusing. Nothing weird to it. So x should be bigger, so that only option that is bigger is 2.2 kilo ohms, and that is then option C for this one to be. Okay, question 34. They say in this circuit we have the following. R1 has double the resistance of R2, and they want to know what is the ratio of I1 in R2 comparing I2 to R2. Okay, so this is our setup. I1 going top to R1 and R2 going down to I2 to R2. Okay, so again, just put in your own values. If we have an I total over here to be, let's say, 9 amps, and R1 is twice that of R2, so it's 2R, okay, so let's say just 2 ohms and 1 ohm, doesn't really matter. It means you should know that it's going to split, okay, so the R's is in a ratio 2 to 1. It means the bigger the resistance, the smaller the amps or the current will be. So the bigger the resistance, the smaller. In a ratio for 9, a 2 to 1 ratio will give you this to be 3 amps and that to be 6 amps, because if we plus them together it should be our I total again. Okay, that means if we say that I1 is a third to be of the I total, then I2 should be 2/3 of the I total, because they should plus them together, because we have a ratio I is inverse to R. So that means that I1 equals I2 to be that it's 3 to 6 amps now, values. But that's not true. 3 isn't the same as 6, okay? So we need to see, or you need to know that an equal sign and a ratio sign isn't the same thing. If we have an equal sign, you need to make sure that the math is correct. So how did we get I1 to be the same? I said 3 times 2, okay? But then it changes to 2I1 to be I2, and that option isn't to be found. So how can I change it again so that I have a mathematical correct equation for I1 and 2? It means if we have 2 times, no, not 2 times, but the half of I2. It will be the same as I1 because 3 and a half of 6 gives you 3, and that is your correct option for A, where the half of I2 equals I1, and that is then in the correct ratio as well.